Hello everyone, it's me your YouTube friend. Today's our topic name is subject is database management system, and our content is a structure of DBMS. First of all, we will see the what is DBMS. A database management system is a software system designed to manage database efficiently. The structure of DBMS contains a multiple components and layers that helps in the data storage, manipulation, and retrieval. The diagram in the PPT presents a layered architecture of a DBMS from the users at the top of the physical storage at the bottom. Let's explore each layer in detail. We can see in the image now. First, first four are users. First one is Navy users, application programmer, sophisticated user, and data administrator. Let's see the one by one. Types of user. First one is a Navy user. Use application without a database knowledge. Means these users interact with the database without knowing its complexity. They often use application interface like ATMs, web forms that hide the database operations. And second one is application programmers write code to access a database. Means these are the developers who write the code and application programs that access the database. They use programming language and APIs to create user interface and logic. And third one is a sophisticated users use query tools directly. Means these users interact with the DBMS directly using query tools and advanced database functionalities. They have a deeper understanding of the database. And fourth one is a database administrator. Means manage the entire DBMS. Means DBMS are responsible for managing the entire DBMS. Their task includes managing user access, ensuring security, optimizing performance, and handling backup. And second one is interfaces and tools. Um, and uh, Interfaces and tools contains application interfaces, application programs, query tools, and administration tools. Let's see the one by one. First one is the application interface. It allows the interaction with a database. Means these provide a why for application programs to interact with a DBMS typically through APIs or embedded SQLs. And second one is application programs perform operations on data. Means these are the user developed programs that helps in the data entry, reporting, and retrieval. Uh, Often using applications interfaces. And third one is a query tools. Query tools means direct SQL execution tools. Means sophisticated user use the query tool to write and run SQL queries directly against the database. And fourth one is the administration tools used by a DBMS for monitoring. These tools are used by DBMS to monitoring and managing the data systems effectively. And third one is the compilers and interpreters. First one is a linker, compiler and linker, and DML queries, DDL and DML, and query processors. Let's see the one by one. First one is a compiler and linker. It converts the application code. Means these converter the high level code of application programmer into a object code This object code can interact with the DBMS through compiled queries. And second one is DML and DDL, used for the data manipulation and definition. Let's see the one by one. First of all, DML means data manipulation language. These are SQL commands such as select, insert, update, and delete, used to manipulate the data in the database. And DDL means data definition language. These these SQL commands like create, alter, and drop, which are used to define and modify database structure. And third one is a DML compiler, optimize and organize queries. Means this component compiles DML statement and organizes them for efficient execution by converting them into a intermediate form. And next slide is storage manager components. Um, First one is a buffer manager, second one is a file manager, and authorization and integrity manager, transaction manager. Let's see the one by one. Storage manager is here. Evaluation engine through the these managers. Let's see one by one. Buffer manager means manage the memory buffers. Means responsible for managing the memory buffers. It decided what that should be kept in the main memory and what should be read from or write written to disk. And second one is a file manager, controls the file structure, means manage the structure of a files in which data is stored. It ensures data is stored or retrieved the currently. And third one is authorization and integrity manager, means security and rules, ensure that only authorized users can access or modify the data. It also manipulates the data integrity consistency, like primary key, foreign key, etc. And fourth one is a transaction manager, ensures ACID compliance, ensures the database remain in the consistent state by handling transactions. It manages the acid means atomicity, consistency, and isolation and durability properties. And last point is disk storage, means where the data is stored. Let's see the one by one. Disk storage and with conclusion. Uh, Disk storage means first one is data. Data means the actual data stores in the database. Second one is indices, means these are the data structures that improve the speed of data retrieval operations. Common indices includes bit trees and hash indices. And third one is a data dictionary. Means contains the metadata such as the information about tables, columns, data types, constants, and user privileges. And fourth one is statistical data, means includes the statistical information about the database such as the table size, index selectivity, query execution patterns, etc. This helps in the query optimization. How and conclusion of this is the we can store the actual data indices, metadata, and states, ensure the efficient data access and management, architecture ensures the security and performance and integrity. Uh, and the conclusion of this topic is the structure of DBMS is designed to ensure the seamless interactions between users and stored data while ensuring the performance, security, and integrity from the user level interfaces to low level disk storage management. Each component plays a critical role. This layered architecture allows the DBMS to function efficiently, providing robust support for large scale data operations. Understanding this architecture helps in the grasping how database handles complex operations internally, making it easier for you guys and a professional to design, query, and manage relation database effectively. And today we will stop here. Thank you.